All right, so really quickly to catch up anyone who was absent, and I forgot to start this recording on time, so the rest of the class is already working diligently. So in our warm-up up here, we saw the 5, 12, 13 Pythagorean triple. In both of these, we have a dilation of 3, 4, 5, so we end up actually with 6, 8, 10, and 6, 8, 10 again. As we shift down to our area problems, we need to remember that the area of a triangle is half of the base times the height when base is perpendicular to height. So, and for anyone who's been confused, I'm going to walk through this again, so it'd be good to have like our head up and be paying attention and watching this happen again. When we see the isosceles triangle here, we do not have a right angle. This angle is shown as being not right, right? It doesn't have a right angle. So we physically drop in altitude, and we know that when I draw a vertical line to a horizontal line, this is a 90. We could use the Pythagorean Theorem and say 5 squared will equal 4 squared, because we know that this cuts in half, plus a squared, or I guess I could say h squared here because that's the height. Or if we recognize that this is a Pythagorean triple, we don't even have to do the Pythagorean theorem. If we don't recognize that, we would end up, well, that's 25, 16. I subtract the 16 from both sides. H squared is 9. We could take the square root, and that is how we get our height of 3. Thinking back to what we've done in previous years, but this is why, like, you know, some of us might need to review because you come from 12 different elementary schools. A triangle is half the size of its related rectangle. Meaning, if I turned this into a rectangle with base of 8 and height of 3, it would actually have the area that is 24. But since the triangle only actually takes up half of that area, half of the 24 is 12. Walking through that again in our trapezoid over here, we again could do the Pythagorean theorem or recognize that this is a 3, 4, 5 right triangle, because when the hypotenuse is 5 and the leg is 3 or 4, the only option is the other number, right? 3 or 4. Mathematically, like, we can prove it. That has to be true. So, we break up the trapezoid. Composite shapes should always be broken up, right? It will make your life easier. Now, for those of you who are curious, I don't have to break this up. There is a formula that I could use that would solve the entire trapezoid together. But we don't know that formula. And who wants to add another thing in, like, well, if you have this memorized, it would, like, no, forget about that. Just break it up. We know rectangles and we know triangles. So, area of this rectangle, 3 times 4, is 12. Area of this triangle is half of that, right? Because it has a base of 4. It has a height of 3. So half of 12 is 6. We put them together, and we make sure we have a label of 18 units squared. Are there any questions up to this point? Up in the top section? Which one? All of it. I didn't know how to do it at all. Were you here when we did Pythagorean Theorem? Okay, you and I might want to chat at extensions probably, because we might need to just go back and review solving the Pythagorean. What is probably messing with you, Adam, is we did all this based off memorization. And it's okay if you don't have this memorized yet, but there are Pythagorean triples that actually over here it might be beneficial for you to write down. We have these certain sets of side lengths that can be scaled, right, multiplied by anything, and we know that it's still a right triangle. So sides of 3, 4 and 5, we know make a right triangle. We can do the math. We can check the Pythagorean theorem. So, for both of these, we were using the fact that 6, 8, and 10 is that same triangle, just doubled, just scaled up. Another Pythagorean triple that we sometimes use is 5, 12, 13, and we can check the math on that and prove that, yes, that will always be a right triangle. That is how over here we didn't actually have to do the Pythagorean. But if we forgot about that, right, we would set up a squared plus b squared equals c squared, and we could solve out the Pythagorean to solve this. So if you'd like some extra practice on that, please come do math with me at extensions. I get bored at extensions. I just stare out the window at the construction guys and I make them feel awkward. So please come do math with me. I'd really, really, really like to do math with people. Moving down to the next parallelogram, the tiny trap door here is this little 1. Well,
that makes sense. Never mind. I totally was confused, but I know exactly how I was supposed to do it.
I have no idea what to do. Wait, I know exactly what to do. So, this 15 is not given to us, right? We have to solve it. So, I think I did this on a Post-it note yesterday. It must have been. Adam, this should help you out, man. Like this right here. I am going to set up the original Pythagorean theorem. A squared plus b squared equals c squared. It feels so good. We know it will work. Leg, hypotenuse. Right, so I've got a leg of 8. The other leg, I don't know, because the 15 is not given to you, right? I'm just out of extra copies of notes, so I have to use this copy that I've already written on. So I'm going to call that h for the time being. Sorry, squared, not a question mark. And the hypotenuse of 17. This is when we got to use our calculator to help us out, because I sure don't know what 17 squared is. 8 squared I do know. What is 17 squared? 289. I know, some of you memorized them. I know up to 15 squared. After that, I get a little confused. Then we do the algebra, working towards getting h by itself. So, to do that, get rid of everything else. So, we subtract 64. And then we have h squared equals 225. How we undo something being squared is we square root. And that's how we get our h of 15. Just by knowing. I mean, like literally you just have to like guess and check in your head. Like if somebody said take the square root of 68, right? Not 64. In my head, what I think is, okay, 64, I know is 8 times 8. So 68, it's 8 point something. Like that's what I'm going to tell. Like literally that would be my answer, is it's 8 point something, because I know it's bigger than 8. Really my answer would be go get a calculator. Like literally, like seriously, we will be, I don't even know what example to give, but like there are times at my house and I'm just like, where is the calculator? Like that I don't just do this because I'm your teacher. That's just life, guys. So actually, 8, 15, 17 is another Pythagorean triple. There are a lot of Pythagorean triples. You don't have to memorize like any of them. But it's not bad to memorize them. Adam? Yeah. Like. All right. So. Careful. This 9 is a lie. I mean, kind of. The bottom is 9. But if I look at just the triangle, it's 8. So the formula for each of our triangles is the same. It's half of 8 times 15. That's a 15, sorry. I know it, yeah. Pro tip, don't wait to do the half.
I was so confused on what the heck to do, and then right when we got to it, I'm like, oh, never mind, I just know.
Half of 8 is going to be easier than half of whatever bigger number you're going to get, so do the half of 8 first. That's 4 times 15, and then that gets 60. So if this is 60, and this is 60, and this space is, 15, because it's 1 times 15, what's our total area?
135.
130. Aha, units squared. Questions? Have you done the next one? What's that?
Is it possible to calculate it?
What is it? Oh, back up. What is it?
Would it be possible to not draw that line down and get that one back to the rectangle and calculate it?
Oh, it's a trapezoid.
Yeah, you can use that spooky theorem that he talked about. He's not going to teach it because you shouldn't have to memorize it.
Oh, that is a trapezoid. I was trying to figure out
It's not a spooky theorem. I'm debating if I want to make you guys derive it right now. Like, because now you talk about it as spooky, and I want to show you it's not spooky. It's like, it's actually pretty nice to derive.
Being like weird or hard, I was just saying,
Really quickly, to show you how this works, really quickly, a trapezoid now the other side could also be tapered down as well. A trapezoid, cut this off, move it over here. A trapezoid is a rectangle. So the formula is, if we call this base 2 and it's the entire before I cut it off, and we call this base 1 but it's just the top before I add it on, the formula for a trapezoid is half base 1 plus base 2 times the height. That's it. That's it. That's your trapezoid formula. That's it. Sure you did. I believe you.
As soon as you said base
I
1
just
base
totally
2, I was
forgot.
like, base 1 base 2 divided by 2. You should apply that.
So here, if we wanted to apply that formula, I keep losing my Post-its. Oh, yes. Well, here, I'll write it down right now because we're about to use it. If we wanted to use that formula here, since I recognize this is a trapezoid, it's half the sum of the bases, which, guys, that's an average, times the height. You could also write it as base 1 plus base 2 over 2 times the height. Either way, base 1 I always call the smaller base. Doesn't matter. Base 2, I already calculated the height. It's also a Pythagorean triple. Are they all whole numbers? Not 9. Not 9, it's 7. I was waiting for you to, like, I figured when we got down here, you would be like, it's not 9, it's 7. But yeah, so then we calculate all this. What do you get? 180?
180 units squared.
And also, if I summed these two, I'd get the same thing. So there you go. Guys, the other class did not get that formula, and the other class is not going to get, well, they did not get the simplified radical thing that we're going to talk about. So you guys are getting like all sorts of bonuses today. Flip to the back, and let's go all the way to the bottom.
Are we finally ahead? Is this a breakthrough?
You will be after tomorrow,
Oh, by the way, did you get your second vaccination?
Monday. Remember, I'm behind the other teachers because I blame Miss Allie for breaking the website. No, don't. She got upset when I said that as a joke, so I should stop saying that because I think Miss Allie actually has emotions. I just didn't realize that. So I'm not saying what I'm saying is not true. What I'm saying is true. It just hurts her feelings because she didn't realize that was going to happen. So yeah, but it's. She accidentally clicked the thing too many times, and the site crashed, and then there were no open spots left because people had accidentally clicked things multiple times. You know when you print something and it doesn't come out, so you click print 5 more times, and then you end up with 6 copies of it? Yeah. That's what happened.
More accurate, what she was trying to do is she was reloading all the pages, and each time she reloaded, she was trying to go through because it wasn't working.
Yeah, so she accidentally completed it 7 times. Yeah, that's not helpful. I want you to show me how awesome you are by figuring out what the heck we do with this cube, and then likewise, what the heck we do with this rectangular prism to find the diagonal. And what I mean by that is the diagonal would just be across the square. Right? A diagonal across a square. But this is not just across a square. It is from the front bottom right to the back top left. So it is the diagonal. Same thing here, except it's front bottom left to back top right. So take a moment. Really, I need you guys to try these on your own because I really want to see if you can do it without me. See if you can figure out what is that diagonal. What is that diagonal? Take a few minutes. I'll probably maybe give you 5. As Dr. Smith would say, don't do nothing. Yeah, Jeff, my favorite professor that I've ever had. Sorry, if I haven't talked about him in this class, Jeff Smith from Otterbein, my favorite professor I've ever had, would always say, do anything. Just do something. Even if it's draw a line, draw a picture, draw an anything, do something. So if we look at this image and we start asking ourselves, well, what do I know? What do you know about a square? Square. What do you mean it's square? You're not wrong.
The sides are the same.
All right, keep going. The sides are the same. Yeah, but we don't care about area. So I appreciate that you're doing things, but I think we're on a path that doesn't go anywhere. We should turn around and come back and pick the right path. So I agree with what you were saying, but I don't care about area. Adam? It is not. It's going to have to be longer. So, let's not guess, right? We're better than guessing. Let's not guess. Thought? We could not do that because why are there 3? Yeah, but what's the bottom of this?
60 squared in the first place is 3,600. So
what is the bottom?
about fell over.
What is the bottom You ever step and like your foot gets caught on something? I got caught on my chair. What's the bottom of this shape? No. What is the bottom? A square. What do we know about squares? The edges are perpendicular. This, stick with me, I'm about to blow your mind. This is a 90-degree angle. But I need to clean up right there. So where this solid front line meets that dotted line, the bottom of this object, right, is a square. Please draw that 90-degree on your paper. I also know that this edge is 60. What if I think about like the shadow of our diagonal?
It's a triangle.
I love how you said triangle.
So, guys, my triangle that now I'm going to call black, green, purple, kind of pink, I guess, black, green, pink, that's a right triangle that is 60, 60, and some other side that we can figure out.
Wait, how do you know 600? How do we know what you said is 60?
Cube. So, hey, this doesn't work when we all talk at the same time. So I like that like people are thinking, but we can't address every question when we're all talking. So first off, it's a cube. Every edge is identical.
Yeah, so
Does that satisfy your question?
So we know the dotted line on our triangle that's standing up, right?
So the triangle that I drew is flat on the bottom. Okay?
Oh, you're saying that if you mirror it to the bottom.
No. Just not mirror. Just listen. All I did, forget about the whole top of the cube. Rip the whole top off. Okay, rip it off. It's stuck.
Oh, those.
It's like the map that you can
Our cube. Okay? Forget about everything but the bottom. Okay? The bottom is flat like this on the ground. The front edge is 60. This edge is 60. And we're going to calculate the diagonal. So on your paper, draw a little right triangle that is 60, 60, and then we'll solve the hypotenuse. And grab a calculator and do that.
It's the hypotenuse, or the hypotenuse is 72 squared.
72 squared?
No.
It is the square root of 7,200 is what you should be getting.
Yeah, for 72. They took the 0 off the 60.
So guys, what you just found is this bottom diagonal. Right? You with me? Now what we want to do is lift this up and say, okay, from here, if I lift it up to this corner, now what does it measure? Well, guys, do we know what this edge is? 60. So we've got the base of the triangle. We've got the height of the triangle. Is the bottom of a cube 90 with the side of a cube? Yeah, so this is a right triangle. There's a right triangle inside of here, diagonal. Right? There's like a diagonal right triangle. Hey, hold up, back up. Be careful when you say numbers out loud that you make sure they are correct. It's not 720. Back yourself up. It's not that either. It's the square root of 7,200. So let's make sure that we have this work together. This is what your paper should look like. We should have the diagonal. We should have the diagonal of our cube drawn across the bottom. We should have a right angle indicated. We did 60 squared plus 60 squared equals c squared. I'm calling that bottom line c. And we solved it out. It's about 84.85, but that's kind of gross, so radical 7200. You can just leave it as radical 7200 if you want. Are there questions on how I got to here? And guys, that is ignoring the rest of, ignore the rest of the shape. I'm just looking at the bottom. Adam. A calculator. Like that's all 60 squared I put in a calculator, plus 60 squared I put it all in a calculator. So 60 squared is 3600, right? Plus another 60 squared, that's going to be another 3600, so I get 7200. That is your c squared. So remember, this all goes back to, if we're doing the Pythagorean theorem, we're going to be using a calculator because squaring, especially big numbers, it's pretty tough, and we want to make sure we do it correctly. So does that make sense for how I got my 7200, Adam? And then because we don't want c squared, we want c, we either do the square root in the calculator, right? If I type in square root of 7200, I get my 84.85, but I could just leave it as 7200, under the radical.
So would that mean your side length, so that means bottom length is 7200, right?
Radical 7200.
And then your other leg would be radical 3600?
Well, but radical 3600 is 60. So now to figure out the d that I'm writing purple, but I haven't really color-coded it on my picture. I don't even know what color this actually is. So the diagonal triangle has this bottom edge that we said is radical 7200. The vertical edge of the cube, it's 60 because it's a cube. So this is our Pythagorean theorem, right? Hypotenuse squared will equal leg squared plus leg squared. And again, calculator. I can't do this math without a calculator. So I get d squared is 10,800, but that's the length squared. So if we square root it, it's approximately 103.92. Oh, stop it, Nick. You know what I mean. Math is hard.
It's fun though. I got it to 85, and then I was like, it's more than 84, but less than 85.
Yeah. All right, let's talk about simplified radical form really fast. You, very soon, are going to be looking at 3D objects. You might have already started looking at 3D objects, depending on how far ahead you are in your homework. And they like to kind of mess with you a little bit. Really, it all comes down to realizing that that is the same length as this, or that I could drop another height in the middle, or that I can cut this in half and actually make it 3. All of that's just kind of visual type things. But this number, 3 radical 2, that's what seems to be messing with people, so let's talk about it. If this is 3 and this is 6, the hypotenuse, I don't like that they're using h. By the way, we don't use h for hypotenuse. It's almost always height. I still don't like that they're using it though. Oh crap, they tell me you don't know what the h is. So sorry. Not that it's 6. I think I said that a moment ago. No. So I'm going to set up hypotenuse squared equals leg squared plus leg squared. Okay, that is my Pythagorean formula. I just wrote the c squared first. So 3 radical 2 squared equals, well, I know my one leg is 3 squared plus b squared. When I square a simplified radical number, I square the 3 and I square the radical. So when I square the 3, I get 9, and when I square the radical 2, I get 2. Careful, because remember, the radical just comes off. That is actually 18. Because this hypotenuse is actually just radical 18. Now, I'm not going to solve your height for you right now. But let's talk, like, wait, why? What? Why? The reason they didn't write it as radical 18 is they look at radical 18 and say, is 18 a perfect square? No. But is a factor of 18 a perfect square? Yes. 9 is. So I think about radical 18, and somebody's like, hey, you can split 18 up into 6 and 3. Well, fine, that actually works perfectly. If somebody says you can split 18 up into 6 and 3, Akshai's going to yell at you and be like, those aren't perfect squares. So instead, you're like, oh, wait, that doesn't help me at all. What would help me is if I split this up into 9 and 2. You don't have to put the little tail on the end. I just like closing my square root. So, is this true? Yes. 18 is 9 times 2. This is still mathematically true. Then, is radical 9 times radical 2 the same thing as radical 9 times 2? Yes, we could mathematically check this. I don't have time right now, but we could. It's true. So then we say, well, radical 9 is just 3. But radical 2 is kind of poopy, so we leave it. That is how they got to that funky looking number. Really, it's just radical 18.
So what's that funky number because
So, let me give you another example. Sure. Square root of 99 can be broken up into 9 times 11, which can be broken up into radical 9 times radical 11, which could be 3 radical 11. Now, what sucks is because I'm writing on the screen, anyone watching the video can't see anything I just wrote down. I just realized that. But whatever.
sucks for you.
All right, friends. Hold on. Is that time? What time do we end?
3:40.
Yeah, okay. So we have a couple minutes. I'm going to come around with wipes. If you have any questions on any of the, I didn't even label that section. The applications in like the quote unquote real world applications, these that we skipped over, please come work with me at extensions. Right? We kind of skipped over those and we probably will not go back to them. But if you have any questions, please come work with me. You guys don't really have anywhere to go yet, because the other classes are so easy. I doubt it. So that you guys understand what's happening, Mr. Estes works with